Hello everyone. So in this video we'll look at how we can use the pumping lemma to show that a language is not regular. So I've been given a language L and I've been asked to prove that L is not regular, and I have to use the pumping lemma to prove that it is not regular. So here are the steps that we'll be following. What we are trying to do is we are trying to prove by contradiction that L is not regular. So the first thing that I do in contradiction is I assume. So I assume that L is regular. Now what the pumping lemma says is that for any regular language, the pumping lemma holds. I will have to have a pumping length. I will have to, for all strings longer than the pumping length, I will always be able to find a substring in the middle which I can uh, expand as many times as I want. So the next thing that I do is I say that um, there will because L is now regular, because I've assumed it to be regular, I take a pumping length P. L has to have a pumping length according to the pumping lemma. So I take the pumping length P. Then next what I do is I find a string belonging to L which is longer than P. So let's say my length is 3, then I find a string of length 3 or 4 or 5, any of those. Next what I do is I divide S into X, Y and Z, and here I'll have to take all possible ways to divide it. So in the last video we saw that for a to the power n, b to the power n, we had 3 ways that we could choose. So in the next video as well we'll take a look at that same example itself, but we'll do it more formally. So we'll have to take different cases in this fourth point. So we'll have to take all possible cases that can be made, that y is in the a part, y is in the b part, y is in some part of y is in a, some part of y is in b, that way. So we'll have to take all possible ways, and finally the last step is to show that no division of S into X, Y and Z can satisfy all three of my pumping lemma conditions, which was that y needs to be greater than 0, the length of y needs to be greater than 0, x, y to the power I and z should belong to L for any I. So if I can find even a single I for which x, y to the power I, z does not belong to L, that's fine. I just need to find one I value. And the third condition was that the length of x, y put together should be less than or equal to p. So lastly, I just showed that no division of S into X, Y and Z is going to satisfy all three of my pumping lemma conditions. So this is the general procedure that I'm going to follow. And at the end, when we say that no division satisfies all three pumping lemma conditions, we can safely conclude that that's a contradiction, because somehow we cannot pump L, or L is not conforming to the pumping lemma, which means that L must not be regular, it cannot be regular. So this is the general procedure that we'll be following, at the end of which we'll get a contradiction. And in the next video what we'll do is we'll look at using the pumping lemma on a to the power n, b to the power n. So that will be the example that we'll be taking in the next video, and we'll use these exact steps on that and then prove that a to the power n, b to the power n is not regular. So stay tuned for that video, and in the meanwhile do make sure to give this video a thumbs up, subscribe to my channel and share the video with your friends so that they can also learn. See you next time.